Hey, welcome to The Explainer. So today we're going to dig into a really critical question in AI. Why is it that these incredibly powerful autonomous agents can be so, well, fragile? We're going to explore a new framework called SHIELDA, which is designed to give these agents the kind of resilience they desperately need to have.
So let's start with the central paradox, right? We've got these amazing AI agents that can reason through complex problems and build multi-step plans. But for all of that brain power, they are surprisingly brittle. You poke them the wrong way with one tiny unexpected error, and the whole system can just grind to a halt. So what gives?
Okay, so the real problem here comes down to a fundamental difference in how they work. Traditional software is deterministic. You put X in, you get Y out every single time. An error is usually pretty straightforward, like a network connection dropping. But an AI agent, it's stochastic. It's all based on probabilities. And that means its errors can come from a flaw in its own thinking. And that makes our old ways of fixing bugs pretty much useless.
Yeah, and this is where all our old habits just completely break down. That classic try-catch block that developers have been using forever, it's just not going to cut it here. The researchers behind SHIELDA put it perfectly. These static tools just can't probe an agent's complex decision-making. You know, it's kind of like trying to fix a mysterious engine problem by just checking if there's gas in the tank. You're not even looking in the right place.
Okay, so if the old tools are basically obsolete, what's the plan? Well, that brings us to SHIELDA. This is a framework that's been built from the ground up, not just to catch an error, but to act like a diagnostic specialist for these really unique AI failures.
What really makes SHIELD AI so powerful is its structure. It's what they call phase-aware. And what that means is, it understands that a task has different stages. First, there's reasoning, then there's planning, and then there's execution. So instead of just seeing an error pop up at the end, SHIELDA can basically rewind the tape and trace that failure all the way back to find out where the thinking actually went wrong.
At the heart of SHIELDA is this really clever idea they call the triadic model. It's basically a three-part playbook for how to recover from any error. It breaks down every solution into three different dimensions. Let's walk through them.
First up, we've got local handling. Think of this as the first responder on the scene. What's the immediate action we take right now? The options are pretty varied. It could be something simple, like just retrying the action after a pause, or it could be much more complex, like completely repairing the agent's plan, or even calling in a human for help.
All right, next up is flow control. So after you've dealt with the immediate problem, what happens to the overall mission? Should the agent just continue on to the next step like nothing happened? Or maybe it should skip that failed step altogether and just move on? Or was the failure so critical that we need to abort this whole line of action? This dimension decides the big picture direction. And its third and final piece of the puzzle is state recovery. This is all about cleaning up the mess. Did the error actually cause any lasting damage? If not, great, we do nothing. That's a no-op. But if it scrambled the agent's internal memory, we can roll it back to a clean checkpoint. And if the agent did something out in the real world, like, say, sending a wrong email, we might need to compensate by sending a retraction.
So theory is great and all, but does this triadic model actually work in the real world? Let's check out a case study with an agent called AutoPR, which is designed to automate coding tasks on GitHub.
So picture this. The agent tries to push some code and bam, permission error. At first glance, you'd think, okay, simple operational thing, right? The agent's first instinct is to just try again, but nope, it fails a second time. And that's our first big clue that the real problem is hiding somewhere much, much deeper.
And this is where SHIELDA just shines. Its whole phase-aware process kicks into gear. First, it classifies the immediate symptom, an error during the execution phase. But when that simple retry doesn't work, it's like, okay, time to escalate. It dives into the logs, performs a root cause analysis, and what it finds is that the real problem wasn't in the execution at all. It was a reasoning error, a faulty task structuring that happened way back at the beginning in the planning stage.
And boom, here it is, the aha moment. Let's break this down because it's pretty cool. Over on the left, that's the agent's original busted plan. If you look closely, you'll see it's trying to modify a file in the .github/workflows directory. Now that's a huge security no-no. The system is built to block that. But check out what SHIELDA does on the right. It doesn't just throw an error. It crafts this new, smarter prompt. It literally tells the agent, hey, you can't do that. You are explicitly forbidden from touching those files. And then it tells it to find another way. This is intelligent, targeted correction.
And what happens? A total success. Guided by that new, intelligent constraint, the agent comes up with a completely different and totally safe plan. It creates a new file just to notify the user, which achieves its original goal without breaking any rules. That right there is phase-aware recovery in action.
So for all the developers out there watching this, you're probably thinking, okay, this is awesome, but how would I actually plug this into my agent pipeline? It's a great question.
Well, the beauty of it is that it's designed to be modular. Take a look at this diagram. You see the main LLM agent in the center, doing its thing with reasoning, planning, and execution. SHIELDA is that exception handling module off to the side. It's not a brain replacement, it's more like a guardian angel, watching over the agent's actions and accessing its memory to provide that critical layer of resilience. So to get this running, you really need a few key pieces. I like to think of it like a medical team. You've got the classifier, that's your diagnostician, figuring out exactly what's wrong. The registry is the medical library, a playbook with all the possible recovery strategies. The executor is the surgeon who actually carries out the chosen procedure. And the escalation controller is the emergency contact for when things get too tough and you need a human expert. Of course, none of this works without great logging and monitoring. That's the patient's chart that makes the whole diagnosis possible.
Okay, let's pull back for a second and look at the big picture here. What does all this really mean? Because this is way bigger than just handling a few errors more gracefully.
Look, what we're really talking about here is so much more than just a glorified try-catch block. SHIELDA represents a total paradigm shift. We're moving away from just reacting to errors after they happen, and we're moving towards proactively engineering systems that are smart enough to diagnose and recover from their own complex internal failures. It's all about building for resilience from the start.
And that really leaves us with the ultimate question, doesn't it? As these agents get more and more powerful and more autonomous, how do we build systems that don't just fail gracefully, but that actually learn from their mistakes? A framework like SHIELDA isn't just a safety net, it feels like a vital first step toward creating AI that can genuinely adapt, recover, and ultimately earn our trust.